How do you do, ladies and gentlemen, and teachers, and boys and girls? I'm Julius Sumner Miller, and physics is my business. And our very special business today I have entitled Adventures in Magnetism. This is a marvelous subject because it is filled with enchantment and with many things we do not understand. As you know, there exist in nature some things which are naturally magnetic. For example, iron, nickel, cobalt, magnetic abundantly, highly magnetizable. But an added phrase, everything is magnetic to more or less degree, because magnetic phenomena have their primordial origin in the motion of electrons. And since atoms of all kinds of stuff have electrons which are in motion, everything is magnetic. So everything can be magnetized to more or less degree, some things very slightly, of course, just as everything can be electrostatically charged, some to more, some to less degree. Question, how can I make a magnet? Here is something that will enchant your soul. I have an iron bar. Iron is magnetizable. It is magnetic stuff. Let me say that this has no magnetic history, none. I'm going to magnetize it. I will put it in this place, in this room, in a north-south magnetic meridian, which is determined by a compass needle here. Here is a compass needle which points north and south. Somebody says, well, it doesn't point north and south, Professor, in this room. No, it doesn't, because I've got lots of alien and foreign magnetic influence around. But supposing this is the north-south magnetic meridian in this room, which it is, I'm going to take the iron bar, hold it horizontally, tip it a little. Now, why do I dip it or tip it? Because here is a needle. If we can get a look at this one, there is a needle which shows a magnetic dip. That's it. Not too reliable in its reading here and now because of the alien magnetic influences all around, including the magnetic personalities in this studio. Now, what was I about to say when I was diverted here by this phrase? Yeah. So the Earth's magnetic field has a horizontal component and a vertical component, and that's why I'm going to do this to the rod. And then with a hammer, I'm going to strike it smartly, as the British would say. Bang, 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 bang. And I have made this bar a magnet. I have magnetized it. Proof. Let me approach one end of the bar to that needle. Watch. Watch. It repelled the needle. And repulsion is the only evidence that a sample of stuff is magnetized. Attraction proves nothing. So I've made a bar magnet. I made a magnet out of striking an iron bar. How else? Supposing I take a bar of iron or other magnetizable stuff, wrap a coil of wire around it, and connect the coil of wire to a difference of potential, such as a storage battery, I make an electromagnet. Here I'm going to do that. I have a battery, I have a wire, I'm going to wrap this bar with the wire, coil of wire. I will show you that this is a feeble magnet from my earlier adventure. Feeble, notice, no action, no action. Now I'm going to energize the wire with an electric current and watch the effect on the end of that rod. Watch it. Aha. And what else? Oh, the wire's getting pretty hot, sure. So I have made a magnet by striking it. I have made a magnet by energizing a coil of wire. Another. Here's a bar. Here's a hunk of stuff. Magnetite. Oh, that raises a very good question. Magnetite is Fe3O4. And so I like to ask, what is the valence of oxygen in this? 3 ions, 4? Oh, that's a good question. But anyway, going to make a magnet. This stuff has astonishing properties. Lodestone, it's called. Hang it up on a string, and it will set itself in the Earth's north-south magnetic line. I'm going to make a magnet out of this bar, which has no magnetic history. Watch me. Somebody says that looks like something mystic. In fact, regarding the hitting of that iron bar, or this business that I'm doing here, if I did that in my native New England in the 17th century, they'd cart me off to a stake for madness. But anyway, I make this an iron bar by stroking. Or consider another better way. Here I have a bar that has been magnetized. Somebody says, that isn't a bar, Professor. Sure it is. It's a bar whose ends have been turned up, and it's a magnet. Oh, notice. Notice the motion. This is the direction of the magnetic field that emanates from this rod being magnetized. So I can make a magnet in many different ways. Problem. Here is a bar of iron, magnetizable stuff, which I have scored a little bit with a file so that it's breakable. Now you know that if I have a horseshoe magnet, a bar magnet, it has some definitive regions called poles, south and north. If I break that bar magnet, as I have done here now with one already, we discover that each one is a magnet. So I have south, north, south, north. Supposing I took a piece of stuff, magnetizable, which has no magnetic history, and I make a magnet out of it. Let me do that. Watch it. Good. Now, here's what we have. We have a bar of stuff with some such polarity defined. Now I'm going to break it. And what do I have? A north-south, a south-north. I ask, what is the pole strength of these separate pieces? Very good question. Another adventure in magnetism. I have here two identical bars, absolutely identical in every respect. Same thickness, same length, same stuff. But I assert that one is a magnet and the other is not. And I can't tell which one is. Question, without any accessories whatsoever, no string to hang it up so it'll set itself in the Earth's field, no compass needle with which to test it, no pins or nails to pick up. How can you tell, just by the interaction of these two, which is the magnet and which is not? Let me show you the dilemma. A, B. They stick. Stick. You get the idea. They stick. They stick. I'm going to turn that one around. Stick. 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 Question. Just by handling these two, how can I determine which is the magnet? If I were a kindlier fellow, I'd give you a hint, but I won't. Wonderful little question. Next question. Iron is magnetic. Steel is magnetic. Nickel is magnetic. Cobalt is magnetic. Question. Is stainless steel magnetic? Is stainless steel magnetic? Oh, watch it. Piece of stainless steel. Horseshoe magnet. Very strong. Watch it. Well, notice. I don't think I'm going to show you because I think it's a very interesting question to leave unanswered. Is stainless steel magnetic? Well, I'm a kind fellow, so I'll show you. Watch it. It is not. Now, supposing I wanted to provide some magnetic shielding. Here is a sliver of steel, which is highly magnetic. Watch it. Sure, highly. Notice the influence of the field at quite a distance. I'm going, whoop, notice, you can't live with immunity in the midst of this stuff. I'm going to put a piece of zinc on there. Is zinc a magnetic insulator? No. Is copper a magnetic insulator? No. Is aluminum a magnetic insulator? No. Is wood a magnetic insulator? No. Is lucite a magnetic insulator? No. Here is a piece of iron. Iron is magnetic. Watch it. Sure. Let us see if this is a magnetic shield. Watch it. Watch. Nope, not a magnetic shield. Remember how thick it is. Watch it. Here is a thicker slab. Watch it. Oh, that's magnetic, all right. Is it an insulator? Watch, because this is tricky. Watch it. Oh, it looks like an insulator. I'm going to do it again. Watch me, because I'm sly and tricky. Watch it. No, it's not an insulator. I am raising a very exciting dilemma. Here is a heavy slab of iron. Is it an insulator? Watch me now. Very cautiously, watch me. I'm going to show that it is an insulator. Yeah, it's an insulator. Didn't pick that up. Now I'm going to do it again. I'm going to show that it is not an insulator. There it is. I want you to worry about that, and that's why I'm not saying anymore. Question. Supposing I had a bar magnet here and a bar magnet there, and I sprinkled some iron filings between. Let's go down here and see that. I have that very thing here. Here is a bar magnet. There is a bar magnet. I put a glass plate on top. I'm going to sprinkle this with filings. Look at the beautiful array that results. Beautiful thing. Now, supposing I had a bar magnet, N there, the S over here, and S here, the N over there. I have a strong magnetic field there. I want to insulate that region. How could I do it? Beautiful. If I sprinkled iron filings there, they would take such a direction. If now I put a heavy iron washer in there, we would find an interesting thing, that the field inside there would be field-free. The region there, field-free, meaning that soft iron is a very good magnetic insulator, which is an exciting thing to recognize. Now, some magnets, ceramic, discs, watch it. One, watch. They are polarized facially, and obviously like poles are adjacent, and you see that I have them running on an aluminum rod. It could not be magnetic. Are you not agreed that these magnetic phenomena are enchanting to witness? And I thank you for watching.